Okay, the easiest way to explain how shared memory really kind of works is to give you an example, and there are a number of examples on the system already, but the two most comprehensive ones are the FrogNet monitor and the communicator, and also, for that matter, the one dashboard uh, JSON script or JavaScript page, dashboard 31, dashboard 32. So the easiest way to kind of explain it is to take a step back from it. The way that we are addressing memory, the thing that makes memory work for us, is Galertner's tuple space as defined by Linda. Okay, so three three-axis addresses into a memory location, or three-axis addresses define a memory location, and the contents of that memory location can be arbitrary, and the physical location of the database holding that information can change without notice, at least without notice beforehand. And you can get notification that the database changed. So quite often the thing you want to do is get that notification and reassert your space immediately, so that then you can figure out where everything else is. But that's not really the point. The point is that you're even though what we're doing is addressing memory three-dimensionally, the real implementation is still through REST. So your calls, the API calls that you make, are actually going to be traditional REST calls, just the same as you're making now. The difference is that you don't have to worry about the message or the servers or the storage or the transport or any of that other crap that we've had to deal with for the last 20 years. All you do is define the memory address that you want to affect and whether or not you want to read or write it. That's it. You do that, you fire it up, and you let it rip, and you're on the air. Now, as a demonstration of that, I'm going to show you a little bit about how the Python version. We'll look at the other two versions, but the Python version of the FrogNet monitor works. So this is a file called sensors.py. The directory we're in is user local bin FrogNet monitor py. The Python version of the FrogNet monitor is the default version. So we're looking in here at sensors, and this is where you get the sensor information, that you put up when we have the sensor list in the little blue box, right? So at the top of this file, so this is the this is the sensors.py file, and what we want to have, we've got, say, fetch sensor detail. What we're looking at is this is the URL that we're putting together, going to database host.frognet. Okay, that's very important. And then the entity, so we're invoking api.php, and we're looking at sensors as the entity, the action is list, and then we're going to encode the sensor name. So we're looking at all sensors with this sensor name, and we're saying limit 1. So we're looking for a sensor with this sensor name is what we're doing. And then all we do is API request here, right? And when we get it back, we say, sensors. So sensors equals the API request, right? What it was returned. And what this is going to be the JSON, right? So sensors is the JSON. And so you can set an individual sensor to the 0th element. Since we only had one return, the 0th element is it. And out of that, we get the sensor ID. If we didn't get a sensor ID, that means we got either an empty or a bad return on the sensor, so we bail. If we did get a good return, then we go back to the thing, and we're doing a sensor data get. So the first one was to get the sensor. The second one is to get the sensor data for that sensor. And out of the sensor data, we're going to pull up the JSON data right here, the JSON data, and we're gonna load it there. And if we don't get an encode error, then what we're going to pass back is that JSON data, right? So we set this up. Yeah, okay, return sensor. Yeah. So we set all this up, and we just make the call up here at the top. Okay, so there's URL live. Here's fetching the sensors for the host. So again, it's going to go to database host.frognet, and it's going to do an action list, right? And then it's going to come down here and deal with it. So this file is api.php, which is the file that's invoked. And we can look at it, up at the top. There's some entities up here. This is some stuff that I thought of a while ago, and I'm not sure it's truly accurate anymore. Users, teams, that kind of stuff, but it's still here. The important thing here is sensors, and a little further down there's sensor host. Sensors, sensor data. Sorry. So sensors are sensor ID, the frog ID, the sensor address, the sensor network, the sensor name, the sensor type, sensor location, and then some tags, right? And all of these are set up for us, but the ones you can search on are sensor name, blah. You can search on any of these actually. And sensor data is from just the JSON data, right? So it takes a sensor ID. The sensor ID is the same one that comes back. This is the primary key for the sensor table. So sensor ID is the primary key for the sensor table, and it's also the primary key for the sensor data table. I don't think all of these are used in the sensor table. I know sensor ID and frog ID are. I think the ones that are used are actually the sensor name, sensor type, and sensor location. I think sensor address and sensor location, sensor network were actually the same thing. So this is an old definition. It's not old definition, it's the current definition, but it's got some junk in it already that we probably need to get in there and take a look at. Bad stuff, but historically, that's where it came from. Anyway, so we look at those are the table definitions, and then below it are read body. So bad, and then JSON read body. JSON read body makes sure that what comes back is a clean JSON array. Blah blah blah. Build where and params, and then exec statement. So here is exec statement. This is the critter that actually runs the database query. So you're doing a MySQLi here, a query, and you're doing a prepare. You've got the statement, and then it executes the statement and returns it. So this is, this is standard programming structure. You can probably follow along with it fairly easily. So you got fetch all that brings back, and then you've got, so down here then, all right, so here's a create, right? So if you're going to send up to create a new sensor item, and again, so it's called sensors, but it's really the tuple table, right? Before I realized that I was working with tuples, I just thought of them as sensors. And so it's a bad name for it. It's something we need to change. But think of sensors as tuples, and and you'll be okay in this system. So when we have a tuple, this is where we're going to create it. We create an envelope around it. So it's got the date, the create date, things like that, and then the actual values. You can mess around with this api.php all you want, but the bottom line is that what you're doing here, you know, just like in the C compiler doesn't get rid of the calls to the assembler underneath it. What it does is it generates that. So what we've done is we didn't get rid of the REST calls underneath it. What we did was get rid of all the complexity that was necessary and replace it with something that gives us actual memory. Because really, what were all those messages doing in the first place? What they were doing was pretty much straightforward exchanging memory in just about every case. I wrote a lot of that stuff. I wrote internet multiplayer game servers for Electronic Arts, Sierra Online, and Wizards of the Coast, and I know exactly what's going across those wires. So exchanging it for live memory that can be read and written without having to set up weird messages and be able to set up all the PHP and all the other CGI or whatever CGI whatever that you're putting into it is hugely valuable. So we're going to leave it with this for now. Uh, in the next video, we're going to take a look at the C++ and C# implementations for the FrogNet monitor. Uh, it's the same thing, or a very similar thing, just in a different language, because the FrogNet shared memory is language agnostic, right? You can get to it from any language you need to. So we'll show that next, but this is a good example of how to read shared memory and how to query based on tuple conditions. So set it up, take a look at it, and we'll move on from here. Okay, have fun. Bye.